In this video, we're going to find the domain of a few different functions in interval notation. Now, the reason we're looking at these is because these are examples of functions which are continuous on their domain. So when we ask, where is this function continuous, we're essentially asking where is it defined, what is its domain. There's a few things we want to look at when we're looking at domains. We want to see, are we ever square rooting negative numbers? Are we ever dividing by 0? Or are we taking natural log of 0 or less? Those are kind of three things that are bad for the domain. It's good noting that odd power roots are great. They're fine. They don't affect the domain. But any even root, like a 4th root or 6th root, you do need to make sure that you're not taking the root of a negative number. So we're going to start with this one. We have f of x equals x squared minus 5. And we want to find where is x squared minus 5 greater than or equal to 0? Well, that's where x squared is greater than or equal to 5, which I think you can convince yourself that's going to be where x is greater than or equal to square root of 5, but it's also where x is less than or equal to negative square root of 5. So if I go ahead and draw the number line just to kind of help me out, I have two interest points at square root of 5 and negative square root of 5. And what we're saying is that x can be bigger than square root of 5, it can be less than negative square root of 5, and it can equal either of those values. So those are the values that are in the domain. If it's anything else, if it's between negative square root of 5 and square root of 5, then we'll have something, let's say it was 1, that's between those values. Then we'd have something like 1 minus 4 under a square root, which would be a square root of a negative. We don't want that. So now that we have this, what do these two shaded pieces of the interval look like in interval notation? Well, this is everything less than negative square root of 5, so we'll start it with negative infinity, up to and including square root of 5. Since we include square root of 5, we're going to have a closed bracket. We're not going to have anything in this interval, so we're going to skip over it. And then on this side, we're going to have square root of 5, including square root of 5, and everything bigger. So my interval notation answer for the domain would be negative infinity to square root of 5. Union, this is a negative square root of 5, and it should be up here as well. Positive square root of 5 to infinity. That would be my answer for the domain and where this function is continuous. Now, we have another problem, which is going to be a little bit more interesting. So here we're going to have the function 1 over x plus square root of 5 minus x and plus natural log of x plus 4. And each of these chunks needs to be defined. What that means, this chunk tells us that x can't equal 0. This chunk here tells us that 5 minus x has to be greater than or equal to 0, which means that 5 has to be greater than or equal to x. And this chunk here tells me that x plus 4 has to be greater than 0, can't equal 0 because we can't take natural log of 0, which then tells me that x is greater than negative 4. So I'm going to draw three number lines here. For each part, we have the number line, we have one part that cares about 0, one that cares about 5, and one that cares about negative 4. The first place is defined everywhere except for at 0. So its domain looks something like this. The second is defined only for values less than and including 5. So its domain looks something like this. And this last one is all values bigger than negative 4. So it doesn't include negative 4, and the domain looks like that. So if we look at all the places where all those pieces are defined, well, it's not going to be, we're going to look at negative 4, 0, 5. First, we'll see that they're not all defined at negative 4 because the last one isn't. They're not all defined at 0 because the first one isn't, but they are all defined at 5. The last one isn't defined for values less than -4. All three are defined for values between -4 and 0, and also all three are defined for values between 0 and 5. But the second one isn't defined for values greater than or equal to 5. So just to kind of summarize what we've done, we've drawn 3 different number lines for the 3 different conditions we had, and we looked where is it defined on all 3 number lines we had. We got this. So now if we want to write our final answer in interval notation, we're going to look at what chunks do we have. Well, this chunk here is all numbers between -4 and 0, but not including -4 or 0. And this chunk here is all numbers between 0 and 5, including 5, but not including 0. And we don't have the other 2 pieces. So my domain would just be -4 to 0, not including 0, or -4, union with 0 to 5, including 5, but not 0. And that would be the domain of this function, and also where it is continuous.